Question 2.9 of the electrochemistry unit asks to calculate E cell under non-standard conditions for the following cell diagram. We see that the anode, as always, is on the left and that the cathode is on the right. Using the abbreviation ANOX, we know that oxidation takes place at the anode, and we see that aluminum is oxidized to aluminum 3+. We also can take notice that the cathode reduction takes place using the abbreviation RED-CAT, and we see that tin is reduced to tin 2+. Moving on to step 2, we balance the half reactions and multiply by the common coefficient to get rid of the electrons on both sides. And from the overall balanced equation, we see that 6 moles of electrons were transferred, which will come in handy when we are calculating E cell with the Nernst equation. Moving on to step 3, we use the standard reduction potential table to find the standard E cells for both half reactions. Looking at the table, we can see that tin has a positive 0.154 voltage and that aluminum has a negative 1.676 voltage. This can then just be plugged into the following equation of E standard cell equals E cathode minus E anode, and we get the following 1.83 volts for standard E cell. Using the Nernst equation, we are able to calculate E cell under non-standard conditions, and we have the value standard E cell 1.83 volts. We have the 6 moles of electrons that were transferred, and now all we have to find is Q. Q can be calculated with the following, and that can be translated with our balanced overall reaction as this. Plugging in the numbers, being sure to remember the squares and the cubes, we get the answer negative 0.0895, which is logged. From there it's easy, because all we have to do is just plug and chug with our given values. After plugging and chugging, we see that the final value is 1.83 volts, or the exact answer, which is 1.827 volts. Part B of question 2.9 asks similarly for the E cell potential under non-standard conditions given the following cell diagram. We see that yet again the anode is on the left and that the cathode is on the right, and that at the anode, oxidation is taking place of tin to tin 2+, and then at the cathode, reduction is taking place for lead from lead 2+ to lead. Balancing the half reactions, we see that 2 electrons are transferred during this process. Looking at our standard reduction potential table and our half reactions, we were able to find the standard E cell voltages. We see that for lead, there's a negative 0.125 voltage, and that for tin, there's a negative 0.137 voltage. Plugging in those values to the standard E cell equation, we find that we get a total of 0.012 volts. Finally, using the Nernst equation, we have our values yet again for standard E cell, which is 0.012 volts, and we know that 2 moles of electrons were transferred during this process. Again, we are to find Q, and using the concentrations that were given at the beginning of the problem, we plug in the value. Taking these values, we plug and chug, and find, after plugging in all of our things, that the final voltage is 0.06615 volts.